All right, let's continue on chapter 1, Introduction to Statistics, part 2. All right, we're going to explain a little bit more concepts in statistics. So the subject of statistics is largely about using the sample data to make the inferences about the entire population. So put in simple language, using the simple sample data to predict about the entire population. So this is the essential goal of the statistics. So now let's take a look at some important terminology. First of all is perimeter. So perimeter is a numerical measurement describing some characteristics of the population. So anytime you're talking about perimeter, it's pointing towards the population. So it's like they have a corresponding relationship with each other. Perimeter used to describe the population characteristics. Okay. And then statistics is numerical measurement describing some characteristics of the sample. So statistics is used to describe the sample characteristics. Statistics describes the sample characteristics, and typically using the numerical numbers. Okay. And we also categorize the data as a quantitative data. So quantitative data or numerical data. Another way of saying that is numerical data, meaning we're using number to represent the data, to consist of number representing the count or measurement. So for example, you can say the weight of the supermodels, right? It should be, let's say, 100 pounds. Okay, 101 pound, something like that. Okay, they definitely is numerical data. So used to representing the characteristics of the weight of the model. Okay, and also the age of the respondents. Right, so that's definitely a numerical data. Also, another way of categorizing data is categorical data. You also call this qualitative data compared to quantitative. Qualitative is non-numerical, so all the categorical data is non-numerical data. So typically consists of names and labels representing categories. For example, you could say gender. Gender definitely is numerical. It's a categorical data. Gender of the professional athletes. Also the t-shirt numbers, shirt numbers on professional athletes used to replacing their name. And that's also a categorical data. So let's say number 17 or number 20. That actually represents each athlete who wear those numbers. Okay, so those are the categorical data. Another example could be your favorite color, right? Favorite color. Okay, so definitely it's a categorical data. And then working with the quantitative data could be further described by discrete data or continuous data. Discrete data or continuous data. Okay, discrete data is typically the numerical number. Possible values is either finite number or countable number. So the simple language used to describe discrete data will be finite, countable, numerical data. Okay, that's a typical discrete data. So number of possible value could be 0, 1, 2, 3, and then move on, right? So for example, the number of eggs a hen lays in a farm. So the number of eggs typically will be 2 eggs, 3 eggs, and you never expect to have like 1.5 eggs. That's not possible. Also, the number of people attending 4th of July parade. That's also discrete data. It could be a huge number, but it's still finite countable. And if you hire enough people to counting the amount of people attending the parade, you could definitely get a number for that. So although it could be a big number, but it's still finite countable number. So this is the essence of the discrete data. And continuous data is result from infinitely many possible values that corresponds to some continuous scale that covers a range of the values without gaps, interruption, or jumps. So for example, meaning this typically continuous data has infinitely many possible values, infinite many possible values. Very important, and then all the values in a given interval are possible. Okay, so the amount of milk that a cow produces, for example, 2.343115 gallons per day, right? That's so. For example, a cow could produce 2 to 3 gallons of milk, right, on a given day. So right here, anything between 2 to 3 are possible. So it could be 2.1, right? 2.15 gallons, 2.2. So you have infinitely many values available here. That's what they mean by infinitely many possible values. And also a given humidity, right? A humidity on a given day. That's also a continuous data. Also, could be amount of rainfall. On a rainy day. That's also typical continuous data. So you typically have infinitely many possible values associated with all those different kind of variables. Yeah, so another level of we use different level of measurement to classify the data. So we use level measurement. So let's start with the first level, nominal level measurement. It's categorized by data that consists of names, labels, categories only, and the data cannot be arranged in a sequential order, right? In order scheme, meaning sequential order from high to low, from low to high, or high to low. Sequential order. Okay. So for example, it could be a survey responses like yes, no, undecided. Okay. So that's a typical nominal level measurement. Ordinal level measurement involve data that could be arranged in some orders, but difference between those data values cannot be determined, either cannot be determined or meaningless. For example, let's say a course grade A, B, C, D, F. Right? It's almost impossible to measure the difference between the student who get an A in the class or get a B in the class. It's very difficult to quantify the actual difference. So that's why that's the order here. Definitely getting an A is much better than getting a B. But the difference between A student and B student cannot be determined, right? Or meaningless. And then also interval level measurement involve data that could be arranged in order, and difference between any two data values is meaningful. So however, there's no natural zero, there's no starting point, zero starting point. So for example, like the time in years, right? Year 1000, year 2000, the difference between any like it's meaningful. However, nobody knows where the time starts, right? There's no starting time. No starting time. So nobody knows that when the time starts. So that's why there's no starting point here for the time. And ratio level of measurement is an interval level with additional property that has a starting point. Okay. So for ratio level, there's starting point. 0 indicates none of the quantity is present. So for example, like the price of the textbook, let's say on those websites have $0 with some shipping cost. So $0 represents no cost, right? And a $100 book costs twice as much as $50 book. Okay, so that means the difference means it's meaningful. Okay, and it also has a sequential orders and with a starting point. Okay, and this is a summary of what we talk about: level of measurement, nominal level, categories only. Ordinal level is categories with some order. Interval level is difference, but no starting point, no 0 starting point. Ratio level, that's difference, and that's a starting point.